Good day, everyone. We are the Group 3 of Section Napier, and today we will discuss about subatomic particles, ions and molecules, chemical formulas, and how to name compounds. Please take time to listen and understand the thought of our video. Thank you so much.
Ions are group of atoms with positive and negative charge. Positive charge is called cation while negative charge is called anion. A molecule is a group of two or more atoms held together by chemical bonds. They distinct to ions because unlike ions, molecules are electrically neutral.
Subatomic particles, also called as elementary particles, are particles that are much smaller than atoms. Subatomic particles are any various self-contained units of matter or energy. There are three main subatomic particles that are formed: protons, electrons, and neutrons.
So now let's talk about protons and neutrons. Protons and neutrons makes the nucleus of an atom. Protons have a positive electrical charge and they are all identical to each other. Neutrons have no electrical charge and said to help hold the protons together because protons are positively charged particles and should repel each other.
Now, we will discuss about chemical formulas. Chemical formulas provide a lot of information about chemical substances, such as how many atoms they are made of. There are three types of chemical formulas: molecular formulas, empirical formulas, and structural formulas, respectively. Here, we will tackle about naming binary compound, ionic compound to be exact. Ionic compounds will form one type of cation. In naming this, we should name the metal first, then next is the non-metal element by adding the suffix "ide" to it. For example, NaCl. The elements present are sodium and chlorine. First step is to name the metal. Na means sodium. Next, add the suffix "ide" to the non-metal element. Cl or chlorine is the non-metal element. So, the final answer is sodium chloride.
If a metallic element has cations of different charges, that cation will be indicated by its suffix for its older name, or by Roman numerals in parentheses after its name in writing the stock system. The older method uses the suffixes OUS and IC to denote the lower and higher charges. In the cases of iron and copper, it will be ferrous or ferric, cuprous or cupric, because the Latin names of the elements are used. For example, CuCl2, where Cu 2 positive cations connects with the 2 Cl negative anions to form a neutral compound. Its systematic name will be copper 2 chloride because copper's oxidation number should be indicated in the parentheses. Its older name is cupric chloride. Another example is CuCl. The copper's charge is positive 1, that's why the systematic name will be copper 1 chloride and the older name will be cuprous chloride.
Next are covalent compounds. These compounds are composed of two or more non-metals which are found at the rightmost part of the periodic table. The thing with covalent compounds is that to name them, one should use prefixes that indicate the amount of an element in their respective compound. These are mono for 1, di for 2, tri for 3, tetra for 4, and so on and so forth. These prefixes are added before the element's name. However, if the first element is only one, just state its name. For example, Hi will be named hydrogen monoxide. H2O will be named dihydrogen monoxide.
Polyatomic ions are ions that contain two or more elements. Polyatomic compounds that contain oxygen are called oxyanions and generally have the suffix "ate" and "ite." Eighth form contains more oxygen atoms than the ith form. Some elements form more than two different polyatomic ions. To name these ions, add the prefix "per" to indicate it contains more oxygen than the eighth form. Hypo is used for ions containing less oxygen than the ith form. For example, ClO or hypochlorite, ClO2 chlorite, ClO3 chlorate, ClO4 perchlorate.
So let's talk about acids. Acids are formed from certain binary hydrogen compounds that are dissolved in water. Binary hydrogen compounds contains hydrogen and another chemical element. However, not all binary hydrogen compounds are acid. Let's take ammonium as an example. Binary acids came from hydrogen plus any nonmetallic element. To name a binary acid, place a prefix hydro and a suffix "ic" to the stem name of the nonmetal element, then add the word acid. For example, chlorine. Its root word is chlor, so its acid name is hydrochloric acid. Another example is fluorine. Its root word is fluor, so its acid name is hydrofluoric acid.
Returning to the subject of acids, another type of acidic compound will be discussed. These are oxyacid, named for the presence of oxygen atoms on the anions of these acids. To name these compounds, the name of the anion must be identified first. Then change the suffix of the anion to "ic" if it was ate, or "us" if its suffix was "ite." Don't forget to add the word acid to the end. Example: HClO or hypochlorite will be hypochlorous acid. HClO3 or chlorate will become chloric acid.
Thank you so much for the time, guys. Hope you did enjoy and learn from our video. See you next time.